Okay, so Conway's Game of Life is always a huge favorite for me, and I love doing it as a programming exercise. So let's run the program here, and you can see the various generations being iterated over. This particular one flows up here, and then it reaches stability there. So I'm going to walk through the test code that I wrote for this Game of Life exercise. I'm going to show how I laid out test data in that code to make it easy to read and understand, which is always key. I'm going to do some live refactoring, because as soon as I look at code, I always want to improve it, whether it's mine or someone else's. I'm going to demonstrate some tough and interesting naming choices that I had to make, because naming is so important. And I'll be my own worst critic. I'll be indicating areas for improvement, a couple of little small pyramids of doom. All right, let's get started. Thank you. Okay, so let's start off by running the program here with some example data. And here we can see a Game of Life flowing across, and then it gets fixed at that point. It stays that way because there are no more iterations with that pattern. Okay, so that's an example of it. Let's just run it one more time. You can see it mutates. Looks like it sort of slides across the screen. Sliders, as they say. And then it goes fixed. Alright. So let's take a look at the code. And let's start off, of course, by looking at the tests. So you can see here, test documentation. Conways Game of Life, show an empty board, starting with a pre-filled 4x4 board. Can create a new board cell count numbers, and then can create a new board based on cell counts and rules, and can do 3 iterations. And starting with a pre-filled 5x5 board, create the cell count numbers, and a new board based on the cell counts and rules, the same as that one. A couple of different sizes, and they're all passing. If I do npm run coverage, you can actually see it actually runs it here, because I have a runner that I normally comment out here at the bottom. Let's go down to this. So if I comment that out, then we get 100% coverage and all of our tests run, which is good. So we can run it in both ways here. So now let's take a look at our actual, let's start off with our tests. Got a pretty good idea what they do behavior-wise, but let's see what they're actually doing here. And we can actually get rid of this down here. Now, nice thing is always to zoom out a little bit and just see what sort of shape this code has. So here's all of our test code here, and you can see with the help override here, we can see it's a little bit hard to read. Let's zoom in one. Okay, so you can see there's an now to describe, and then we have one example up here with no befores or anything, and then we have a nested example here, and at the same level a nested example here. This is the 4x4 and the 5x5 board, and each of them has a before each that will apply to each of the 3 and 2 examples that they have. One of the things I've learned to be careful about is having a before each at the top. Although it may be useful, it will then be used by all of the indented example groups. So it can get a little hard to see how your dependencies are kind of flowing down. That can be the cause of confusion and, of course, bugs. So in this test code here, at one point I did have a before each, but I moved the code out of it because of that problem. Alright, so that's my test code. Let's zoom in a little bit more. And you can see here, one of the things about this test code is that, hold on one second here, is that I went to some effort to actually lay out the test data. I was going as far as to put a little space in to make it possible, because when you're debugging and trying to figure out what's going on with this with these algorithms, it's really helpful to actually be able to view the grid the way that certainly a human, usually does. I could have put this in much harder to read format to set up the data and to check the data later on. But this made it much more easier to debug and to try changes. So I actually strip out the space when I'm actually setting up the board for processing. And so here you can see a test of the algorithm that counts up all of the neighbors and gives these counts. So you end up with a numbers board, new board numbers. And then we have a test here that, let's see, counts the new board and then counts the board from values. Now maybe this could be named a bit better. Maybe it could be like count new board values and then count board from new board values to make it more obvious. That's certainly a possibility there. This test here is a little bit suspect, in fact, because it does this run n times 3, but it expects the result to be true. And I think this is actually left over from when I didn't know how to exclude something from code coverage. So I'm going to look to remove this, because just making sure it's true is not actually if I want to do it 3 times and see the final result, the third generation, I should actually check the output to do that. So that's maybe something I should be doing. All right, so now let's move down to, so the 5x5 is kind of like the 4x4. It's a different pattern, which is good. And here's all the numbers, which I actually manually calculated. Got nearly all of them right, and then I had to check a couple, and it turns out my algorithm was better than me. And here's what the next generation should look like. If you start off with this one, it ends up looking like this, and again, it's quite easy to see that visually. So there's all of our tests for the code and for all the various methods. They could all be put inside one class, and then not tested, but as private methods. But I think it's good to always consider testing them in this case, and I went with testing all of them. All right, so let's take a look at the application code. So let's come over here. All right, and there's our run n times iterator there. And let me just go to the bottom of the code while I'm here, because I think what I'm going to do is I'm going to steal this line. You look at code, you always want to do something, right? And I'm going to put that there so that my code coverage can ignore that runner there, something I've done a couple of times recently. And so now I'm actually going to get rid of this here. I still have that idea of adding one that checks the output, but for now at least, I am going to do that, run my tests, and of course we will have this problem. DAW X. Okay, save that. Good. Let me do run coverage. 100%, excellent, okay. And I'm still doing the linting and testing with this. I'm just not doing the code coverage. Okay, so now let's look at let's see some of the things I had to use here that are of interest. Let's take a look, hold on. All right, a little bit of Pyramid of Doom here with this indenting. So I'm probably going to take another look at that with our traditional for loops here. So I'm always looking to see if I can use a for in, or even better, a for of. But the naming, I tried to go some effort here. So count neighbors, given a board and a row and a column, it's basically a cell position. I want to count my neighbors, and then I'm going to push that onto this row, which gets added to new rows. I'm not sure if new rows is really the best name here, but That's what this does. Calculates the boards, calculates the rows for a new board. All right, now here's the real heart of the algorithm, in fact, and I went through the code here, the naming of this, many times. In fact, if I click here, I think you can see my last iteration. It's pretty interesting. I actually had west row, east row. Like now I have north row and south row. It's kind of confusing. But I changed them many times to get names that I think will work. So, oops, let's get back up. So, the mental model I came up with for counting cells around you was compass points. And I rarely use such acronyms, but I figure here, northwest, southeast, southwest, northeast, south. I figured every one. These would be common, like date of birth and SSN, some of the few acronyms that are pretty common, at least in Western and US culture. But these ones, are just English. So those are fairly recognizable, and they do describe the compass points around a cell in a grid, the north to south, the east to west, northeast, northwest, southeast, southwest. So it's pretty appropriate, and I think it's very helpful in the visualization in reading this code. This stuff here, it's a little bit dodgy. Edge is really like the bottom or the right edge, so that's a little bit confusing. Using our just the result of these operations here, if the row is 0, then north is basically true. So these are setting up booleans. So we've got north, south, west, and east, and then we've got the north row, the top basically, and the bottom, and the right and the left. And at one point I actually had names like east, like left and right, and above and before and after. And I realized that was actually confusing because I was using several different nomenclatures, including my compass point directions. So I tried to make most of the stuff use the compass directions naming. And you'll see it play out here. And I'm actually going to go down here and I'm going to move these 4 lines. I'm going to put them here. I think it's easy to go through the simple points first. I always run stuff. Okay, so not north. So north is the top row. So if it's not the top row, then, and we're counting our neighbors here of this current cell that we're on. Diagram would be helpful here, but I'm going to keep going. So as long as we're not on the northern edge, then our north, if it's alive, counts as 1. A little bit of code that I kind of compacted over a few iterations here. I started off with a ternary, and then I realized that I don't really care about the false, and so I tried out this, the and, if this, then gives us value, and that worked. So the same for the east. So east is like the right hand edge, and so unless I'm at the eastern or right hand edge, then calculate this. And I start off by setting them all to be 0. So these calculations here, only if these things are true do I change them to be 1. Okay, the setting of them to be 1. Okay, so I do the first 4, I don't know if it's cardinal directions, but the first 4 compass points, and then I do the northwest, the northeast, southwest, southeast, by looking at both of those conditions, basically seeing if I'm in the corner, top left, top right, bottom left, bottom right. And then finally, I count up the 8 cells that I've calculated that are all around me, and I return that count. So that's my count neighbors. So mostly this was a naming exercise, and it still looks like this, perhaps repetition here that could be extracted, but with so many things changing throughout the formula, would that extraction actually make it more readable and easy to change and easy to spot bugs? I'm not sure. I don't think so. No pyramid of doom here, so that's pretty nice. So it's fairly easy to understand, I would say, this count neighbors. Calc board from values. So we have a little bit of pyramid of doom here going in. But you can see here, and we'll see this a couple of times, goes through the rows, and for each row goes through the column, so it's going through the cells. And here's the heart of our formula here, which I had to look up to remind me. I kind of guessed it, nearly got it right, but then I looked it up. So if it's, this is to be compact, it reads a little backwards. So the cell that we're on, if it's neighbors, sorry, if it's alive, start here. If the cell's currently alive, this is how the formula goes. And its number, this is in the numbers board that we've calculated, is 2 or 3, then it's going to stay alive. Otherwise, and this is a little bit tricky here, because in compacting these lines, this else has to go off this if. Like if I didn't have these parens here, the else would go off that if. And that's not that obvious, so this is a little bit smelly here. But for now, this else goes off this if, and this is the other rule. If it's not alive, if that cell doesn't have an O in it right now, then if it's got 3 neighbors, this is the formula, then it comes to life. And then we push this onto this row, and then we push this row onto the rows array, and we return the rows array, so we get the new board from that. Alright. Now Istanbul, so code coverage, I ignore this because it's a runner, and I'm still learning perhaps how to have a good way to have code coverage with tests that have a runner that you don't call because it'll run it continuously. So that's something I'm figuring out. So I ignore that, and the same for this. This is also the runner, and this is commented out because this is where if I don't comment it out and I run the test, it'll actually run it. So I just have that set up like that. So that is basically the code. You can see here the heart of it, of running it, does this, like calculate the new board, and then calculate the board from the values, spit it out. And here, I was very excited actually to get the opportunity to use a generator, because I realized I want to be able to give me a generation if I don't have a, even if I have a timer that's spitting out each one, I'd like to be able to call and say, give me the nth generation. And you can do that now in JavaScript. It's been out there for a while. So you put this little star there, your function star, and then your function name. And then, and it may be a more compact way of doing it than I've done it here, but I've done the runner equals that function. And then I use set interval to call it every second, and I use next to give me each time yield, and then it'll pause, and when I say next again, which is what this loop is doing, it'll give you the next one and the next one, and this board will keep being the output will keep being the input, because this is just like suspended while it's going through the iterations. So I was looking for a use. A reason to use a generator recently, for learning purposes, and this popped out as a great example. It's a great way to use it. All right, so there we go. Let's just go back up to the top here, and whenever I see myself using a bunch of methods like this, it tells me nowadays that I should be encapsulating this in a class with methods, which is actually surprisingly easy to do. So I'll probably go ahead and do that as part of my next refactoring. But for now, I'm done. All right. Thank you.